All right, so for this video, we're going to talk about discriminants, so finding the discriminant, level 2. So this discriminant is a part of the quadratic formula. So before we do anything, I want to make sure this is equal to 0. So I'm going to minus the 5 on both sides, giving us 5x squared plus 90x plus 405 is equal to 0 because those cancel out. Okay, so let me write out our quadratic formula. So the discriminant is an important part of the quadratic formula because it tells us kind of like how many roots you will have, how many answers you will have essentially. And so the part of this formula that tells us how many answers you will have is this part inside of the square root. So this part that I just highlighted is called the discriminant. So the discriminant is equal to b squared minus 4ac. So remember how when you use the quadratic formula, if the discriminant was 0, we actually only had one answer? I know that happened in one of our examples. So if your discriminant is 0, you have one answer. If your discriminant is a positive number, you'll have two answers. And if your discriminant is negative, you'll have imaginary numbers. But we'll get into that more later. For now, let's focus on solving for a discriminant, like literally just calculating it. So remember, to calculate this, we need to know what your A, B, and C are. A is 5, B is 90, C is 405. So B squared minus 4AC, let's plug it in. 90 squared minus 4 times 5 times 405. So B squared minus 4AC. So let's literally calculate it. So 90 squared is our B squared minus 4 times 5 times 405. And then you just plug it into a calculator. So 90 times 90. 4 times 5 times 405. Okay. And then 8,100 minus 8,100 is 0. Our discriminant is 0. Are there any questions on this one? Okay, let's type in 0. 0. Let's do another discriminant problem. For the following equation, or for the following quadratic equation, find the discriminant. Remember, it's part of the quadratic equation, so you want it equal to 0. So I'm going to bring over the 8x. I will also bring over the minus 4 later. So that gives us plus 12x. Those cancel out. It's equal to negative 4. Remember, we want it equal to 0, so I'm also going to bring over the 4. That's going to give me 3x squared plus 12x, and then that gives me plus 63 equals 0. So now we have it equal to 0. So this is your A, this is your B, positive 12, and this is your C, positive 63. So we are simply going to plug this in into our discriminant formula. And yes, the 4 always remains as a 4. So B squared minus 4AC. So we have 12 squared minus 4 times A times C. So literally just plugging it in. Okay, so 12 squared is 144 minus 4 times 3 times 63. That gives me 756. And then you subtract it. This gives you negative 612. So your final answer for the discriminant is negative 612. Are there any questions on this one? Let's keep going. Negative 612. Oh, okay. Let's see. What did we do wrong? Let's see. Where's my picture? There it is. Okay, so what did we do? We added 8x on both sides, and then that gave us negative 3x squared plus 12x plus 59. Then we added 4 on both sides, 59 plus 4 gives you 63. That's good. So A is 3, B is 12, C is 63. So 12 squared is 144, and then minus 4 times 3 times 63, 756. That's weird. Okay, you know what? Let's do the very simple thing, which is give up and see what the solution is. B squared minus 4AC. Wait, the A was a negative 3? Oh, do you see right here when I copied it? I like forgot my negative. Oh my goodness. I just like didn't see my negative that I wrote. Okay, so you guys just need to be more careful than me. This is like my, I don't know, third mistake today where I just like wrote the wrong thing. My apologies. But you just need to be more careful than me. I mean, like literally everyone makes mistakes. I'm not ashamed that I made a mistake. I'm just like sad that I took so long today to do your lesson, and I apologize for that. But as you can see, I wrote the negative sign in the beginning and then I just forgot it in the end. So don't be like me, okay? Use your negative signs when they're supposed to be there. Okay. So that's the formula for discriminant. Let's take a look at what the discriminant is for in the last category, which is called nature of the roots. So you're gonna find the discriminant. Actually, before we do that, I'm gonna draw a little flow chart. I guess I can draw the flow chart over here. So when you find your discriminant, you're either going to have it be positive number, or it can be a negative number, or it can just be equal to 0, right? Those are your three options. So let's start with if your discriminant is equal to 0, then your answer should be that it is a real number and that your roots are equal, meaning that your two roots are the exact same number and they are rational. Rational is just like whole numbers and fractions, okay? So real means they're not imaginary numbers, equal meaning that the two roots that you get are the same number, and rational means that they're whole numbers or fractions. And then from this, you're done. Okay, let's say you have a negative discriminant. So what happens if you have a negative discriminant? Then your answers will be imaginary numbers, which really means that because if you take a square root of a negative number, you're going to get something with the letter I in it. I'm not sure if we've covered that before, or if it was supposed to be covered last year, or if it got cut out because of COVID. But just know that if your discriminant is negative, you have an imaginary number because you really can't square root a negative. So that's why it's called imaginary, because you cannot square root a negative usually. And so if you get an imaginary number, then you're done. So those two ends of the flow chart are pretty straightforward. But let's take a look at if you get a positive number. So if you get a positive number, they're real. And then you have to check something else. You have to check if it's a perfect square. I'm just going to draw a perfect square, which means that you have a number squared. So these are numbers like 4, 9, 16, 25, numbers like that. Those are perfect squares because it's something squared. And then I'm just going to write not perfect square. So your positive number can either be a perfect square or it can be not a perfect square. So if you get a perfect square, then your answers are going to be rational. If you get a not perfect square, then it's going to be irrational. And after that, you're done. Okay, so here's your little like flow chart of sorts. And so let's take a look at our problem. Oh, I don't have to zoom out that much. So here's your A value, is a positive one. Here's your B value, it's a negative 20. I noticed the negative this time, I didn't forget it. And here's your C value, it's a positive 96. Here's your formula, b squared minus 4ac, that is the discriminant formula. Let's plug it in. Negative 20 squared minus 4 times a, which is positive 1, and c, which is positive 96. So just plugging it in. And then we get negative 20 squared, that's 400, positive, minus, let's use a calculator, what's 4 times 1 times 96? 384. And then 400 minus 384 gives us positive 16. Okay, so we have a positive number, so I'm going to follow this one. That means we have a real answer. Okay, now let's take a look. Is it a perfect square or is it not a perfect square? Well, 16 is equal to 4 squared, so that is a perfect square. Remember, that's a number right here. So it is a perfect square, which means we have a rational root as well. So we have a real rational root. Okay. Are there any questions on this one? Real and rational? Let me zoom out, I guess. Real, unequal, and rational. I guess I should say it's only equal if your discriminant was equal to 0. Otherwise, it's just going to be unequal always. So real, unequal, and rational. Any questions on this one? Okay, let's go ahead and submit real, unequal, and rational. Next one. I wish I just could, well, okay, I'll just draw the thing again. I'll draw the table again. So remember that your discriminant, you could have it be positive or negative or 0. This means it's real. If you have a perfect square, then it's rational. And then if it's not a perfect square, then it's irrational. If it's negative, it's just imaginary. I'm just going to write that for imaginary. If it's 0, it's real, equal, rational. Okay, so let's take a look at which branch we're going to end up at. Your A is equal to 1. Your B is equal to negative 8. I'm going to remember that negative this time. And your C is equal to positive 41. Here's your formula. Plug it in. Oh my gosh, why am I writing things all wrong? There we go. Negative 8 squared minus 4. A is 1, C is 41. So we have negative 8 squared minus 4 times 1 times 41. So negative 8 squared gives you 64. Positive, because a negative times a negative is a positive. And 4 times 1 times 41 is 164. Okay, and so 64 minus 164 is negative 100. So which path will we end up going? This is a negative number, so I'm going to use the negative and simply imaginary. There's nothing else to say about it. It's just an imaginary number. Are there any questions about this one? Imaginary. I guess for this one, we could just do one more example, and then I'll call it a day. Just because this is like the new stuff. Okay, so let's see. Should I draw the flow chart again? Now let's not draw it this time. Okay, let's take a look at what we have here. This is an A is 1, B is negative 16, and C is 48 positive. B squared minus 4AC. This is our discriminant. So we have B squared minus 4, A is 1, C is 48. Did I get all my negatives? Yes, I got all my negatives. Great. Okay, so what is 16 or negative 16 squared? 256 minus 4 times 1 times 48. Okay, what is 256 minus 192? Okay, so I'm going to draw my not t-table, but I'm going to draw my chart a little bit. So right now we got a positive number, and then we needed to check if it is a perfect square or not. So 64 is 8 squared, so this is a perfect square. And if it's a perfect square, then that means it is rational. So we have a positive number and a perfect square, which means that we will have a real, rational, but they're unequal, because the only time they are equal is if the discriminant was 0. So we have real and unequal and rational. Oops. There we go. Real, unequal, rational. Any questions on this one? All right, let's just select it then. Cool. Okay, that's it for this category. Is that our last category? Yes.